thought science was certain? Well, that is just an error on your part. This was a quote by famous theoretical physicist Richard Feynman. What he meant by this is that you can never be sure what you are studying even exists. This is where quantum electrodynamics, or QED, begins. When you combine the theory of relativity, a theory of gravity, and the theory of quantum mechanics, a theory explaining extremely small particles, you get impossible results to your calculations, like infinity or negative infinity. This is why QED was invented by Paul Dirac. Dirac won a Nobel Prize for his famous wave equation that started QED. This wave equation was used to calculate paths of an electron. What is an electron? Well, the answer is simple, but it depends if you are measuring it or not. If you are not measuring the electron, it is a negatively charged wave. If you do measure it, it is a negatively charged particle. Keep those two facts in mind when dealing with electrons. The problem that QED tries to solve is, what happens when two electrons are going towards each other? Electrons have a field around them, a magnetic field to be more specific. When you have two negatives or two south poles, they repel using the magnetic force. The same happens to electrons that travel as a wave. These electrons repel each other, and a non-existent photon is created. A photon is a particle that makes up the magnetic force. What I mean by non-existent is that it does behave exactly like a real photon, but it can't interact with anything, like a real photon. The reason this happens is the fields of the two electrons interact to create the field of the photon, but without the real particle inside. This can happen to any forces or particles by colliding different particles together. Though this helped move QED forward, it did not solve all the problems that arose until Richard Feynman came in and changed QED forever. Richard Feynman created diagrams that would illustrate all the possible paths any particles could take. By drawing these diagrams, you can get around many calculations and impossible results. Feynman received a Nobel Prize in 1965. Now, the question is, why? Why bother calculating so many equations just to find out if the photon is real, or at what angle will the electron bounce off? Well, if we solve the equations of space and time and apply them to the real world, we will have something amazing. For example, if we use the laws of physics and engineering and apply them, we can make better satellites to make even more discoveries about our universe. I chose this topic because I would like to be a theoretical physicist when I grow up. I hope to win a Nobel Prize in physics since it has always interested me. I think using QED we can find many things, such as how many dimensions we live in and what composes the fabric of the cosmos. I think QED is one of the universe's greatest mysteries, one of the most important mysteries, and I hope the mystery gets solved soon.